when the RMS Titanic was built in the early 20th century. It represented some of the most advanced engineering of its time. Please subscribe. Designers understood that a ship crossing the Atlantic could face unexpected problems. And because of this, Titanic was equipped with various backup and emergency systems intended to keep the vessel operating even if something failed. These systems reflected the growing belief that technology and careful planning could improve safety at sea. One of the most important backup features on Titanic was its compartment design. The lower part of the ship was divided into multiple watertight compartments, separated by heavy doors. If water entered one section, the doors could be closed to limit flooding and help prevent the spread of water to other areas. This design was considered a major safety advancement and was intended to give the ship additional protection in emergency situations. The watertight doors themselves were operated through a controlled system. Officers on the bridge could activate them remotely, allowing compartments to be sealed quickly if necessary. In addition to remote control, some doors could also close automatically under certain conditions, adding another layer of protection. Titanic also had backup capability within its power systems. The ship used multiple steam-powered generators to produce electricity. Instead of relying on a single generator, several units worked together, ensuring that electrical supply could continue if one generator experienced problems. This redundancy was important because electricity powered lighting, communication equipment, pumps, and many other essential systems. Another critical area was communication. Titanic carried wireless radio equipment that allowed operators to send and receive messages over long distances. This system acted as a form of emergency communication, enabling the ship to contact nearby vessels or coastal stations if assistance was needed. At the time, wireless technology was still relatively new, but it represented a major improvement in maritime safety. The ship's pumping systems also played an important role in emergency planning. Pumps were designed to remove water from different sections of the ship if leaks or flooding occurred. These pumps relied on power from the ship's engineering systems and were part of the effort to control water movement during emergencies. Titanic's lighting system included emergency considerations as well. Because the ship depended heavily on electricity, maintaining illumination during technical problems was important for both operations and passenger movement. Backup power arrangements helped support continued lighting in critical areas. The propulsion system itself contained a form of redundancy. Titanic used a combination of two large reciprocating steam engines and a central steam turbine. By distributing power across multiple components, the ship's propulsion system could continue functioning even if adjustments were needed in one section of the machinery. Crew organization was another type of backup system. Officers, engineers, wireless operators, and crew members each had defined responsibilities during emergencies. Procedures existed for communication, equipment, operation, and coordination between different departments. While technology was important, human organization remained essential to how the ship responded to problems. From an engineering perspective, Titanic reflected the mindset of its era belief in layered safety systems. Designers did not rely on one single solution but instead combined structural protection, mechanical redundancy, electrical backup, communication systems, and trained personnel to improve reliability. However, these systems also had limitations. Many were designed around the types of emergencies engineers expected at the time. The ship's safety features were advanced compared to earlier vessels, but no system could guarantee complete protection under every possible circumstance. Looking back, the backup systems of the RMS Titanic remain an important part of its story because they show how maritime engineering was evolving. Titanic was not simply a luxury liner, it was also a technological experiment in large-scale safety and reliability. The ship demonstrated how engineers tried to reduce risk through design and preparation. Even today, many modern safety concepts rely on the same principle. Multiple systems working together so that if one fails, another can continue operating. More than a century later, Titanic's emergency systems are still studied as part of maritime history. They reveal both the strengths and limitations of early 20th century engineering and show how safety technology continued to develop after the disaster. In the end, the backup systems of the RMS Titanic were more than technical features. They were layers of protection, a network of systems designed to respond to uncertainty, an attempt to prepare for failure before it happened. And hidden beneath the luxury and confidence of the era, those systems reflected humanity's growing effort to make the open ocean safer through engineering, planning, and innovation.